Hello and welcome to the Day 2 lecture for Upward Bound Integrated Math 2. Today we're talking about 1 and 2 step equations and how to solve those. It's important to get a couple definitions here, but I don't want to make it too overwhelming. The first one is the definition of an equation, and an equation can be defined by two algebraic expressions that are set equal to each other. So two algebraic expressions that are set equal to each other. Um, what does that mean in terms of what we see? I guess that's the definition of an equation. In terms of what we see, that could be something like x plus 10 equals 30. That would be, those would each be algebraic expressions, as difficult or as easy as they are. And we're going to be solving things like that today. Not only that, but even more complicated versions of that as well. So the solution to an equation is the value for the variable that makes the equation true. In class, I talked about this being the value for the variable that balances the equation, and that's really the same idea. This is just kind of a more direct approach. In this case, we're looking at what does this variable have to be to make this a true statement. Obviously, we could say, well, x equals 52, and that's a valid statement to say that x equals 52, but that doesn't make this equation true, so it's not a solution. For inverse operations, we think of two operations that are kind of pairwise inverse. If I think about an operation and its inverse operation, or how to undo that operation, we think about undoing, how to undo the given operation. We have some that are kind of pairwise inverse operations. We have addition. The way I inverse that or undo that is to subtract it. Subtraction with addition. Multiplication with division. And division with multiplication. Some other things that I talked about in class, if we were looking at squaring something, so I'm just using x as a placeholder variable here. The way I would undo that would be to square root something. And likewise, this goes the other direction also. If I have the square root of something, I can undo that by squaring it. That same process can go on and on and on with different powers and different power roots as well. I kind of generalized these 4 definitions today in class, and I'll do that again. Just to say this, that these 4 things really tell me that I can add, subtract, multiply, or divide the same number to both sides of an equation. Okay, that's kind of the generalization of those 4 properties of equality. What we're really going to look at today is how to solve equations. And the primary idea is I want to use inverse operations to undo what is happening to my variable. And not only that, but also in the opposite direction, or the opposite order of operations. So our traditional order of operations, I'm going with the P version for parentheses, parentheses, exponents, multiplication, division, addition, and then subtraction, we reverse that. Okay, we kind of say we do those in the other direction for the most part. We'll do our subtraction and addition. Usually we're only doing one of those, but this is just to kind of talk about the order overall that we should be following. And so we get our order of operations for solving ends up being not PEMDAS, but SADMAP. Okay, and we talked about that, in class today, and whether you think of this as a P or a G. I like PEMDAS. I don't like GEMDAS or GEMDAS, but I do kind of like the G over here. For instead of SADMAP, it would be SADMEG. That's kind of nice. A little bit easier to remember. I think Family Guy maybe. Let's see. Trying a few of these. To follow order of or the inverse order of operations, all these are actually one-step equations. There's only one thing happening to my x, so I just have to pick the right inverse operation. There's really no order that I have to consider here on this one. Since 7 is being added to x, I want to take that away. On this side, they cancel out, and I get x equals 9. On this one, since 5 is being multiplied to x, I will divide that off. So you notice something different that happens when we undo these different operations. Technically, in this one here, I had subtracted 7 from both sides, so this side would be x plus 7 minus 7 equals 16 minus 7. And plus 7 minus 7 takes me to 0. So I get x plus 0. But when I do this, it's really 5 divided by 5 times x. Well, 5 divided by 5 isn't 0, but when I'm doing the multiplication and division, I need a 1 in front of that x. I want to know what 1x is. I know what 5x's are, but I want to know what 1x would be. So I want to make that into a 1. In fact, there's no way that I can make that into a 0 just using multiplication and division, unless I multiply by 0, but we don't want to do that either, because multiply by 0 on both sides, you're just going to get everything equals 0, and you didn't learn anything. So in this, we divide by 5 on both sides, we get x equals negative 7. For our next one here, 2 is being subtracted from x, so I'll add that 2 to get a 0 in my row here, and then I'll add 2 over here, and I get x is equal to negative 1. Okay, this one's not too bad. Let's keep going, see how we do. Negative 8 is being multiplied, so I want to divide by that. Negative 8 divided by 8 is, negative 8 divided by negative 8 is 1. So x is going to equal 48 divided by negative 8, which is negative 6. For this one, x is being divided by 4. So inverse operation of division is multiplication. So I'll multiply by 4, and whatever I do to one side, I have to do to the other. My 4's cancel out and give me a 1, so I know what 1x is now. And 1x is going to be equal to negative 5 times 4, negative 20. And when we get to our last one in this set, it's a little bit different. 4/5 is being multiplied by x. So technically I want to divide by 4/5. But that's kind of weird to do also. Okay, and I'll show doing that on both sides, and then I'll give a better way that we can think of doing that. So I want to divide by that 4/5, but when we divide fractions, we learned way back when that we really multiply by the reciprocal of the second one. So we're going to multiply by 5/4. So that's really how I'm going to handle this, is I'm going to multiply by 5 over 4. And what that's going to give me is my 5 is going to cancel my 5, 4 is going to cancel the 4. On this side, I'm just left with x, and that's what I wanted. And that equals, and this one's kind of tough, but it really becomes 8 over 1 times 5 over 4. And you can cross reduce if you want to, or just multiply straight across. 8 times 5 is 40. 4 times 1 is 4. And that gives me 10 for an answer. So x is 10. Those were all one-step equations. Let's go ahead and look at two-step equations. All right, for two-step equations, I really want to think of that inverse order of operations, my SAD map. And the way I think of it is I want to start on the same side of the equal sign as my variable. Okay, so my variable's here. And I want to start with the thing that's farthest away from that variable. Well, on that side, the thing that's farthest away is the plus 3. So I'm going to start by subtracting 3. And I get x over 2 equals 16. Well, now I've just turned it into a one-step equation where if I multiply by 2 on both sides, I'll cancel out those 2's, and x will be 32. Okay. Not bad. It works. Same idea on this next one. What's farthest away from x but on the same side? The 3.2 is, so I want to subtract 3.2 as my first step. And so when I do that, on this side they cancel out, and I get x over 2.5 equals 1.4. And then what I want to do is multiply by my 2.5 on both sides. And that's a 2.5. And 1.4 times 2.5 is actually 3.5. Okay. These ones, this will happen throughout our stuff. I don't know why this extra line is here. It's not a negative 101. It's just a 10, right? A negative 10 right there. Happens again down here. It's just a 1. So just a formatting issue. It copied part of the table when I copied it into this document. Not a great thing, but we're dealing with it. So, and it makes life a lot easier than negative 101. So on this one, my first step, I want to subtract 5 on both sides. 3x is going to equal negative 10 minus 5, which is negative 15. And now I want to deal with the 3x. We'll divide that by 3 on both sides. Here they cancel out, and I get x equals negative 15 divided by 3, which is negative 5. For the next 3, again, I want to start as far away from that variable as I can. And this one's a little bit weird because my variable's on the right side. But 12 minus 9 is 3. And over 2. Again, I have a one-step equation now. Multiply by 2 on both sides, and I get 6 equals n. For my last one, there's a couple different ways that you can do it, and I talked about both these in class. Probably the way that we're really trying to see how to do it here to actually make this a two-step equation, not a three-step equation, is I want to divide by 10 first. So negative 3 plus g equals negative 3. And then I want to treat this as a one-step equation. This one's a little bit of a weird one-step equation. Even though there's a plus here, my 3 is negative. So I want to undo that negative 3 by adding 3 to both sides. Okay, when I add 3 to both sides, I get a really cool thing. Negative 3 plus 3 is 0. So g is 0. And last but not least, same kind of idea in that this w minus 1, if I knew what w was, I would subtract 1 first and then divide by 7. So I need to multiply by 7 as my first step. And rarely is multiplying our first step, but in a case like this where there's stuff up in the numerator of a fraction, then I need to do a little bit of kind of do my work out of order a little bit. It's actually the correct order because the last thing that happens in SADMAP is parentheses, and there's kind of like a ghost set of parentheses around this numerator that we usually don't draw, but it's actually there. So multiplying by 7 gives me my w minus 1 equals 7. And I'll add 1 to both sides, giving me w equals 8. Okay. Last thing we have today is a little application practice. I have just a problem here that's written out in words, and we have to turn that into mathematics. Okay. Negative 1. That's pretty easy. Negative 1. Whenever I have words writing out math, the is almost always going to be an equals sign. So it is or equals 8 more than 3 times a number. Technically, that's going to be 3 times some number plus 8. If you write it as 8 plus 3n, that's okay. Just be wary. Addition isn't as big of a deal, but subtraction could trick you on writing things out in words that way. You got to make sure your order is correct. So here we start as far away from the n as we can, so we'll subtract 8 from both sides. And negative 1 minus 8 is negative 9. And then we have 3n on this side. Those cancel out. And then we'll divide by 3 on both sides. And we get that n is equal to negative 9 divided by 3 is negative 3. Okay. Now you're equipped to do homeworks 3 and 4, as well as the application that comes right after this. So make sure you get those done before class next time, and make sure you have a good day, and we'll see you in class.